Okay. You know, it's been the truth throughout the ages, and this is a premise of Platonism, Pythagoreanism, and metaphysics, and that is, if you don't have the primer, then you can't understand anything. Kind of like the Rosetta Stone. However, even all ancient Egyptian translations are horrifically inaccurate, but we can transliterate them literally. However, when you transliterate something literally, then it's kind of like giving a hardcore atheist an ancient biblical text to translate into English, because absolutely all spirit and character of the text will be completely lost and transliterated into oblivion, where you end up with essentially a text that's like a dead corpse. It's like, well, the entirety of the person is there, brain and spleen, but it's dead, it's not working, so it's not actually alive to actually illuminate anybody. And this, of course, is a crude sort of analogy of people that don't actually have the primer to know what a field is or what light is. Certainly the notion of a wave-particle duality is a specious nonsense. First off, Mother Nature has no dualities, and a wave is not a thing. A wave is what something does. There's no such thing as a wave, in principle as meant a noun. Also, too, light is certainly not a particle. This is a misapprehension of the coaxial nature of light, where you actually have transverse electrical, magnetic, and longitudinal pulse perturbations, which are interpreted as, or actually, and I've got a video coming tomorrow about the huge, hardcore, giant hole of the scientific method. People think the scientific method is flawless, but the scientific method only revolves around repeatable experiments, and I'll get into that tomorrow. But if the scientific experiment were anything, it would be a donut with a giant hole right in the center, because descriptions are not explanations, nor are repeatable experiments or discoveries any representation of the accuracy of the explanation of what is going on. Specifically, this is about the polarization paradox. We actually take, and I've got a link below, you can actually take a look at it, or you can type in polarization paradox. We actually take 3 polarizing filters, you place a strong light behind it, and the addition of a third filter. If you actually place the second filter with 90 degrees relative to the first filter, you'll end up with something that's essentially completely black. But if the introduction of a third filter, what happens is that the light is greatly illuminated, and people misapprehend, number one, what light is, and specifically what a polarization filter is, because there's several different types of filters. There's a cut filter, and then there's a pass filter. A polarization filter is a bit of a cut filter, but a polarization filter is mostly a pass filter, and this is what people don't understand. There's actually all these, it's really funny, there's actually a couple huge videos by these quantum theorists that are actually doing the math calculations, and they show you the triple polarizer paradox. They line up 3 polarizers and a light source behind it. When the introduction of the third filter, it goes from black to much, much brighter. It's like, wow, by adding a filter, the subject gets a lot brighter, and that actually confuses the hell out of people. But it only confuses people because people don't understand what a polarization filter is, but primarily the reasoning for their misapprehension is that they don't actually understand what the hell light is. It's not a particle, and it's not a wave, and quantum specifically actually refers to nothing in denotation. Quantum is a BS term used in various countless branches of science that actually doesn't represent anything in hardcore original classical field theory. And I mean, the entire 100% of the electrical grid on the entire Earth is based upon the discoveries, inventions, and writings of Faraday, Steinmetz, Nikola Tesla, Oliver Heaviside, James Clerk Maxwell, and these people had nothing to do with quantum BS. But that's a matter for another video, of which I've made countless such videos on the BS of quantum. I've also made a countless number of videos on light, which you could look up, and I'll continue to make a lot more videos on light, because humanity certainly doesn't understand what the hell light is. And they think it's a particle in a wave. Well, it acts like a particle when it's like this, and it acts like a wave like that. Well, once again, there's no such thing as a wave, and light is certainly not a particle. It's a misapprehension of a coaxial circuit, and also, too, the pulse perturbation, rarefaction, and compressions of the longitudinal field perturbation, which actually makes up light, which is a coaxial circuit. Most people don't know, so what is coax? I think most people don't know what the inside of a coax cable looks like, but it's a coaxial circuit. Look up what a coax inside of a coax cable looks like. The most interesting type of coax cable, by the way, is called a air coax. It's just the type of coax that feeds million-dollar TV stations with tremendous amounts of power, and what they are is two hollow copper tubes that are actually suspended from one another using spiral plastic dielectric, which actually just keeps them separate. I mean, do nothing other than keep them separate, but that's a matter for another discussion. The actual nature of the most efficient coax on Earth is the fact that the center of the ultra-high power, ultra-efficient coax has nothing in the center. It's literally air. They call it an air coax because the copper tubes, one inside the other, smaller one inside the larger one, contain nothing. They're air. They're just hollow tubes. But that's a matter for discussion of field theory. Anyway, the answer to the polarization paradox is that people need to understand, first off, before we get into the discussion of light, and I made countless videos on light, is that a cut filter versus a pass filter. And what is an example of a cut filter? Cut filter is, especially probably a lot of photography people are watching me, is that like a red filter, a blue filter, a green, whatever color the hell the filter is, if you add more and more on them, it gets darker and darker and darker, right? You add a red filter to a blue filter and a green filter and then a puke filter. Whatever the color is, you end up with a diminution or a cutting of the light. And that is the case to a very slight degree from a polarizer, because if you hold the polarizer up to any light source, you end up with less light, but that's the reason that it's actually cutting out a certain pass polarization of the light that's passing through the filter. But that doesn't mean it's a cut filter. It means that it's actually a pass filter. Well, it is also a cut filter because the light is diminished. No, the reason the light is diminished, and it's only being diminished because the transverse component, or one axis, and this again is about comprehending the right-hand rule, one aspect of the light is being cut due to the fact that, and it is by definition a polarization filter, is being cut by the filter. But it's not actually cutting the light. It's actually eliminating out. It's a diminution of the manifestation of light. But a polarizing filter is only causing the polarization of one particular, depending on whether it's the electrical or the magnetic, it doesn't make any difference. 90 degrees relative to the passing light that's actually going through it is being cut. So it's a cut filter is what I'm trying to get to without getting into a long description, as opposed to, it's a pass filter, excuse me, rather than a cut filter. But ultimately, the observation is that a polarization is cutting the light. A polarization filter is cutting the light. But it's only appearing that it's cutting the light, and this is really important because it's actually a pass filter. And that's important to understanding what's going on. Light is a coaxial circuit, as already mentioned. The coaxial circuit of light, the perturbation is longitudinal. Only the transverse components, which are the expressions of the pulse perturbation of the nature of light, are affected by the polarization filter, and are the remanifest given additive conditions which are made apparent and made manifest when you actually introduce the third filter, if you can actually check out the video over here. Or you could take 3 polarization filters and hold them up and introduce a third filter between the two, and you'll actually see that the light actually increases, which is counterintuitive to what people understand a filter to be. Well, yeah, but they're thinking in terms of like a color filter, which is a cutting filter. But this is not a cutting filter. However, the observed effects are that it's cutting the light to a certain degree, and even more so if you orientate it correctly. Like, you know, you point this out at like a shimmering lake waters, or you point it at a sky, it'll make the sky bluer. Most everybody, at least everybody in photography, knows what a polarization filter does. But it's a pass filter. So the second filter is 90 degrees to the 90 degrees relative to the first filter. I have a second filter back here, and the orientation is made 90 degrees to the first filter. You basically have zero light that is passing to your eye from the second filter, but this is incorrect. The perturbation is still present, but it's longitudinal. The transverse component has actually filtered out the manifestation of that light, but the perturbation is still present. People understand everything is capacitance, resistance, permeability, and permittivity. What you think you're seeing as the absence of light, where a secondary filter is brought 90 degrees relative to the first, and everything becomes completely black. But the introduction of the third filter between the two actually remanifests the light. Well, it doesn't remanifest the light because the light was always there, and people need to understand the distinction between light and illumination. Everything we consider to be light is actually illumination, because Like, this is the thought experiment that I've given you countless times before in the case of the invisible man. An invisible man would be completely blind, if there could be such a thing like the Fantastic Four, right? Of an invisible man or an invisible woman, whatever the case. They would never see light, because if someone is completely transparent or invisible, then there is no capacitance resistance. Specifically, there's no magnetic permeability or dielectric permittivity for light to become manifest on the back of the eyeball of an invisible person. But this is a thought experiment that gets people's minds thinking about the nature of light. But also, too, you have to differentiate out light from illumination, but that requires a lot of other lengthy videos, which I've already made. The second filter is completely destructive because it's brought 90 degrees relative to the first. The third filter is completely constructive and sets up an interference pattern with the perturbation to remanifest the light, because everything is constructive and destructive interference, as in the case of light. It's the same reason when we see that particular hypertrochoid pattern on the ferrocell, i.e. the supercell. You know, that pattern is due to the constructive and destructive interference of the divergent and convergent magnetism, well, actually centripetal convergence and centrifugal divergence. We have the force and motion, inertia and acceleration between the dielectric and the magnetic, and we end up with this light pattern. And this light pattern is due strictly to the constructive and destructive interference between the dielectric and the magnetic. And all of it is just simply the magnetic pattern, which actually interferes with the light that's passing over top of the magnetic field. Also, too, we have to, and I have to do that in another video, actually define propagation, transmission, induction, movement, and perturbation, or in this case, further still definement of perturbation in the terms of disturbance. Fields are perturbations and propagations, but fields are not transmissive or move. Let me restate that. No field ever moves nor is transmitted. It's like, well, sure, cell phones transmit signals, and I'm used to be a ham radio operator. Ham radio antennas transmit. That's not the case. The correct understanding of the nature of fields, and this is the understanding also of Tesla and Walter Russell and a very, very few others, is that fields have nothing to do with transmission or movement. They have to do with perturbation and propagation, and this is as per a medium. But in the case of the coaxial circuit, the polarizer is not a cutting filter, as I said, it's a pass filter. And we actually have a transverse right-hand rule gateway. So, and I don't know if people understand, maybe they do, I think I'm completely defining the huge difference between a cut filter and a pass filter. Actually, I wanted to mention something else about the polarizer and the polarizer paradox. It also goes by a couple other different names. Polarizer paradox is the one that I grew up with. I had a lot of people ask me to explain the polarizer paradox. And like I said, first it understands the nature of light. That has to be understood. Then you have to understand the difference between a cut filter and a pass filter. The polarizers don't absorb, as they say. It's like, well, this is absorbing light. You know, if you turn it, it'll even absorb more light. And if you stick another filter behind it, 90 degrees relative to the first, it's absorbing all the light. They're not absorbing light, it's rather the subtractive luminal perturbation through destructive interference. Let me repeat that again, because that sounds convoluted, and it's actually not. It's subtractive luminal perturbation through destructive interference. Really no different than like the supercell over there, where you can actually, the introduction of another magnet, you can completely disappear or vanish out the light, but the light is still present there. You have nearly complete destructive interference, nearly complete. But the destructive interference, and this is the key point that everybody's missing, the destructive interference where you can basically see no light with the two filters present, correctly positioned where you see no light, is not the emission of light. You have complete destruction, but not the deletion of the longitudinal pulse perturbation, which actually makes up the coaxial nature of light. So the light is still present in the form of the perturbation, which we refer to as illumination, because light doesn't move. It's actually a rate of induction. Eric Dollard said this, and famously Walter Russell said this, and superficially that seems incredibly foolish and stupid, but there's actually only one way to actually correctly explain all the phenomena that we know of light, like it slowing down, so to say, 30% as it enters glass. That depends on what the glass is made out of, obviously. And then, quote, speeding back up again after it leaves glass. And that's actually impossible to do if you think it slows down and speeds back up again, as modern science does, because that breaks the law of the conservation of energy. Like actually light leaving glass, it hits the gas and speeds up again. Well, that expenditure of energy is absolutely impossible. The only way to correctly understand light is as a perturbation, which is light can only be, and light, of course, is a field modality. Obviously, light is a field modality. We have electrical, magnetic, dielectric, and so-called gravity, which is nothing other than incoherent dielectric acceleration, but light is a field perturbation. So fields are only perturbations and propagations. There's nothing that is being transmitted by the strict denotation of the term transmission, and there's nothing that's moving. Light does not move. The so-called speed of light is the rate of induction of the ether against itself. And it doesn't matter if you call it dark matter, doesn't matter if you call it ether, doesn't matter if you call it counter space, because the one thing Mother Nature does for certain is she does not give a shit what stupid little idiot human beings call, her works. And this is not works in the sense of W-O-R-K-S, but W-E-R-K-S. I don't know if a lot of you understand the difference between those two. I think a lot of you probably do. Works versus works. That's actually not a term used anymore today in common English vernacular, but I think I actually brought that to full explanation because, like I said, all you have to do is understand the nature of light, which basically nobody does, and then you have to understand what the hell a polarizer is. It's a pass filter. It's not a cut filter. Like I said, you could add all sorts of colored filters and they're going to cut the light down to zero, depending on how dense they are and how many you add. But polarization filters is actually the case if you actually turn them in increments relative to 90 degrees. So if you actually take two filters, one second 90 degrees relative to the first, and you can completely black out the light. If you actually introduce not only a third, a fourth, a fifth, and a sixth, the interesting thing, and it's not only interesting and paradoxical to people who understand what light is and what a polarization filter is that it actually gets lighter. And literally, the more polarizers you add between the first two, the lighter it gets. It doesn't actually get like bright, 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 but I mean it gets lighter and lighter and lighter and lighter, and that blows people's minds, and that's why they call it a paradox. Oh my God! The more filters I add after the two filters, which completely blacks out the light, makes it lighter. That doesn't make any sense. That's kind of like adding like a bucket of ink to some clean water, where it's murky, and then you add another bucket of ink to the same water and it gets black. But then you add the exact same bucket of ink to the clean water and it gets much clearer. And then you add at a certain angle, it's kind of a crude analogy, but anyway, the polarization paradox is actually, from my perspective, it's extremely simple, but it makes absolutely no logical sense if you're steeply rooted in quantum atomism, and that's all quantum is. Quanta, quantity, atomism. The ancient Greeks destroyed atomism thousands of years ago, but we're rehashing that bullshit today. But that's all quantum mechanics is rehashed atomism. And number two, you have to understand what light is. You have to understand what different types of filters are. This is also the reason why people will do, and I've had these calls, this is related to photography, people say, I used a polarizer or an ND filter on my camera to do like a time exposure of a sunrise or sunset. It's like my sensor's burned. It's like the camera's destroyed. It's like, but when I looked through the camera, there was nothing there. You know the reason why? Because all those sensors, doesn't matter what's a Sony or a Panasonic or Tower Jazz, all of those digital sensors and digital cameras are receptive, means the photosites on there, on the silicon wafer technology, is sensitive to a lot more than visible light. In other words, there's all sorts of frequencies of light that are passing through that really dark filter, and you thought that your sensor was not really. I made this mistake at a really early age, and I mean, this was really stupid. I used an infrared filter. It was a really dark one. I put it over an infrared light source, and it was just pitch black. Long before I understood what light was and different frequencies. I was really young, and this was a stupid mistake. And I looked into that infrared. I got really close to it. It was a really bright light source, one of those big torches, like, it's zapping some serious, like, wah, But with that infrared filter over there, it was like pitch black. And I had my eyeballs up to it like maybe 10 seconds. I was like this. Oh my God, my eyeballs were throbbing for a week afterwards. I couldn't see anything. It's the same thing with actually digital camera sensors. They're just because you don't see it, don't mean it ain't there, because electromagnetic spectrum is wide and variegated. And interestingly enough, sensors inside digital cameras can see, even though they don't register on the photographs, they actually see a lot more than visible light. I mean, a lot. Even with the IR pass filter in front of there, yeah, they see a lot more than visible light. And that's how people destroy their cameras, by doing time exposures with like really dark ND or polarizer. Well, there's not much light passing in there. I thought I could do a 5-minute exposure of the sunrise. It's like, yeah, the thing is that your camera sensor is sensitive to more than just visible light. Anyway, this is the answer to, let me sip on some more of this really shitty coffee. Your camera sensor is sensitive to a lot more than visible light. And that is the answer to the polarizer paradox. I hope I explained that simply. Sometimes it's really hard to explain abstruse points of both metaphysics but also field theory, because my mind thinks about that stuff all the time, and like I don't think anybody else's does. They're all like worried about bills and family and feeding the kids and the job and Spot the dog, like wiping his butt on the carpet, and I don't have any of those concerns. So thank you so much for watching. If you like these videos, click the link below. Tell me to jump off a cliff, whatever makes you happy, whatever tickles your pickle. Hasta luego, do svidania, and увидимся, girlfriend.